the focus is going to be on the variants of, you know, nonlinear models. Uh, the other time, I remember I've walked you through different kind of nonlinear models. Um, I started with an exponential model. From there, I go into logistic growth model. From logistic growth model, I think I also walk you through some growth models, and from there I went to Van Baterlanffy growth model. And of course, this is the Van Baterlanffy growth model. But I want to tell you, the Van Baterlanffy growth model is not a perfect model when it comes to predicting the growth. Because when you try to use this on different data set, if you divide your data set into two halves, I mean, if because in you know predicting the growth of fish, we the data we use is length to age data. What if I use a tagging recapture data? Has anybody heard about capture recapture before? I actually want to determine the number of fish we have in a pond. Merely looking at a pond, there's no way I'll be able to tell those fish they're going to be under the, below the water. So, what we do in the, capture recapture approach is just, we also do that even beyond fish, even to other animals. If you really want to estimate the numbers of animals of a particular species, what I'm going to do is that we're going to take a sample of the animals, we're going to mark them, we tag them, then we release them back into the population. Then we're going to take a sample again. Like, out of the sample that we take, how many of those animals tagged in the first occasion were included? And that idea, we're actually going to use that to predict the numbers of animals. So using data set from, tagging, we realize that we're getting the parameters, the L infinity, the K, and the T0. Okay, what we get for them, the interpretation of them will be different. And I'm going to tell you why the interpretation of them, apart from interpretation of them being different, the L infinity and K, the values of them will not be the same. L infinity and K will not be the same when you use length at age data and when you use tagging. When you use tagging data. Okay, this the value when you use I'm trying to say when you use Van Baterlanffy model, the values will not be the same. And not only that, this guy we have a different interpretation for the length at each data. It is asymptotic mean length, but for the tagging is the maximum length. Look at that, different interpretation. And that was the reason why Francis came in 1998. Francis actually reparameterized, he reparameterized the von Baterlanffy model. And in the before the reparameterization, another problem Francis saw is that, the other time when we actually obtain the correlation of parameters, we realize that they depend, right? They're highly correlated, right? Which is a violation. Of course, I told you the other time, there's no problem with that. But the fact that one of the assumption is violated, it should be something of concern. And, what Francis actually did is just like, okay, can we have a way to reparameterize this in such a way that the results will not be different? Can we play around the parameters? And at the end of the day, he was able to have this new model from that. Okay. But yeah, it was able, and where L1, L2, and L3, they actually going to be the mean length at a particular age. Now, some of you may be wondering, what is the essence? since the reparameterization will lead to the same results, why do we need to worry ourselves? Number one, we need to worry ourselves about the fact that the von Baterlanffy model is not consistent. We expect statistical model to be consistent beyond the data that we use it on. So if it is not consistent, then it means there's actually going to be a prediction issue. You get what I mean? And not only that, I'm going to give you this scenario now. This is a court. Okay, this is a court. This is another court. This court is in Minnesota. This court is in Mississippi, state of Mississippi. There's one particular person here committed an offense in the state of Minnesota. It was now being tried in the state of Mississippi. If the nature has it that he committed the offense, if the state of Mississippi established that he committed the offense, of course, they've taken the right decision, but the facts remain, their decision is invalid. Why? Because they don't have a territorial jurisdiction. Does that make sense? The criminal should be tried in a particular state where he committed the offense. That's exactly what we're saying. The von Baterlanffy could give good results, but the fact that certain assumption is violated is actually putting its territorial jurisdiction in doubt. Does that make sense? The fact that they make a good decision in a different territory does not mean it's going to be binding, because they're going to say that particular court does not have a territorial jurisdiction for that. Therefore, even though the criminal committed the offense, whatever decision they take is null and void. Okay, the same thing here. Now, you know what I did for me to be able to demonstrate, that Francis' effort in 1988 yielded a good result. We can actually look at the correlation of the parameters at the end of the estimation to be able to see whether the parameters are not correlated. Now take a look at that. We go back to the original data set using the von Baterlanffy model. Of course, we have the estimates of those parameters at the end, infinity, the H0, and the K. Okay, and we fitted Francis for that same data. Okay, we have an estimate for L1, L2, L3 because we're focusing on Francis, and we continue. And what concerns me is looking at the correlation matrix. What do you see? Do you see any correlation? Do you see any strong one between the parameters? Oh my God, Francis, you have done a very great job because of the fact that between any two parameters here, of course, this correlation is very, very low. Of course, 1, 1, 1 is correlation between the same variable. So Francis' efforts has yielded very good result. So that is the reason why we actually consider that. And from there, we can, using the Francis approach now, we can get a bootstrap. I told you the essence of the bootstrap, the Francis effort. I told you the other time that asymptotic rule may not apply at times because you may not be able to rely on the confidence interval of the regression parameter, because the regression parameter may not follow normal distribution. Of course, we constructed the confidence interval based on bootstrapping Francis, and of course we came out with this. If you take a look at this histogram here, you're basically going to see each of the parameter. The distribution of that is very close to that of normality. Take a look at each of that. Francis is working compared to the one we did before. We have some of the the distribution of one or two of the parameters is kind of skewed. Okay, so this is validating Francis' effort. But let me tell you, there are other parameterization that I don't want to go into now. So, that is left for those who actually want to do more research with growth modeling. Now you can use that to make a prediction, just like what we did the other time with the conventional von Baterlanffy model. Okay, so take a look at that. So we have that. Okay, now the next line of action for today. I know